And just some important takeaways that I wanted you guys to know. So today we've been talking about thermodynamics. Thermodynamics only tells if a reaction will or will not occur naturally. Does not tell you the speed of the reaction. That is for, it's actually not kinematics, it's actually kinetics, as this typo. It's not kinematics, it's kinetics. Those are a little bit confusing. Kinematics is, kinetics. Kinematics is what we covered last week. It's like the projectile motion, it's the physics thing we covered last week. The velocity, acceleration, projectile motion, things like that. Kinetics is for reactions, okay? There's delta G, and then there's delta G standard, which I talked about earlier, which just means that it's at, again, this is a STP, it's standard conditions, right? Standard conditions, right? Which is at 298 Kelvin and 1 atmosphere. Be careful because delta G does change with temperature, so pay attention to what temperature you are given. The same can apply for entropy and enthalpy. Enthalpy, I believe we assume it doesn't change with temperature. That's how the MCAT does it. Most of the time you assume it doesn't change with temperature because it's small changes. But S, you do assume it changes with temperature. From delta S standard to delta S, it could change, right? Sometimes you may actually even assume that I think it doesn't change with temperature in certain cases, right? They'll tell you in the question for sure. But delta G definitely changes with temperature. From delta G standard, to pay attention to what the temperature they give you and which value they give you, delta G or delta G standard, right? And the equation for getting between delta G and delta G standard is this one. Delta G equals delta G standard plus RT ln K. We actually have seen this formula before, right? We've seen, let me clear this. We have seen the formula of, it was this one, right? Delta G standard equals negative RT ln K. Well, if you actually look at it, because that was at equilibrium, right? Delta G at equilibrium, you know, is 0, right? If it's negative, it's favored in the positive direction towards the product. If it's negative, it's favored in the forward direction towards the product. If it's positive, it's favored towards the reactant, towards the left side of the reaction. If it's 0, it's favored both ways. It's actually at equilibrium. So whenever you see an equation of equilibrium, know that delta G is always 0 at that point. Delta G standard at that point might not be 0. Delta G standard is completely different, right? But delta G is 0 at equilibrium. And you know that if you just put this to the other side, since this is 0, you just move this to the other side and you have delta G standard on the right and then negative RT ln K on the left. And that's how we derive that equation actually. But if you're given, even if you're given a non-zero value, as long as you know the K, as long as you know the delta G or the delta G standard, you can always find the other variables in that equation, right? And that you can always transfer that for going from delta G to delta G standard. Okay. Like I mentioned, that was the last slide. Thank you very much for coming. I will stick around for a bit, for about 10-15 minutes to answer questions about this lecture as a whole. I didn't want to stop the lecture midway through any questions because for those who didn't need them answered. Office hours are every Sunday, 8:30 to 10:30. If you have any specific questions, passages, problems, topics, anything that you're confused about, please, I'll be there. A bunch of the other tutors will be there. We'll all be able to answer any questions. We will try and get this PowerPoint and recording out to you. If you don't find them in the next day or so, they will be posted on the in the group me though, so for sure look out for that. Email me, I'll send them to you if anything.